are you guys? So I'm at the New York Hall of Science. You guys might have been there for Maker Faire last weekend. Great. I run a research center there called SciPlay. So this is what I think of as an applied research center for play science and technology learning. We're looking at playful ways to learn science. What I'm going to try to talk about today is about museums, and it'll be in the context of a science museum, but I know a lot of you guys aren't science teachers, but I think the central problem can be thought about in the context of all the different subject matter that you guys are teaching. So this is the essential problem. The essential problem is when you look at the overall lifespan of a person, the orange is how much time you're in school, in formal classrooms, and the blue is how much time you're not in school but awake. So the question is, what can we do? Can we do something strategic with all the blue ocean around the orange that would support the goals of the formal schooling? And there's no reason why we couldn't explore that as a design question. So the green dots are different episodes that people are having in out-of-school settings and in school, and so this person is having a whole variety of experiences, but it really has to do with sort of the coherence of those experiences. Can we make sure that the out-of-school or the museum experiences are reinforcing the schooling experiences? And that's sort of the central conundrum that I'm working on at NISI. So here, sorry about the washed out slide, but I've done work in just learning in informal settings in museums, and you get really high affective response to that learning. But when you go looking for, in this case, science learning, you get little factoids. You don't get big principles being learned. On the flip side, I've done work with tech-enhanced curricula in science classrooms, in middle and high school classrooms. I can move the bar on learning quite a bit for all sorts of students. And you would think these would be better than seat work, and they are, but when I do measure affect and look at kids' change in motivation, engagement, I don't see those things change as much as one would hope. So the challenge that I'm faced with, and maybe one you guys would want to take on this year, is really this one of, can you get those two things to reinforce one another in sort of a virtuous cycle, where the informal elements support affect, that feed back into the formal learning, and on and on. So that's what this project is that I'm working on, called SciGames. It kind of is an attempt to create a bridge between informal and formal, between the museum space and the classroom space. And I'll just give you the top-level overview of that, which is all of this stuff is essentially the SciGame. And I'll unpack it and show you some pictures and try to show you how exciting it looks, but the upshot is that the kids are coming to the museum, playing a game, and in the context of playing that game, data is collected while they're playing and goes up to the cloud, whether they know it or not. And what happens after that is that data from the cloud comes back down to an app that's in the classroom, in this case in the science classroom, that's waiting there for the data, and the kids will have fun in the informal space, which is what they should be doing, and then really rigorously dig into that data in the formal space and invent for themselves Newton's second law or conservation of energy or something like that. And this particular example is what we're calling the Slide SciGame, and it's set up at the museum on our science playground. So just to give you some eye candy about this, there's a before the event teacher registration piece where the teachers are on the web setting up their class. Then when everybody arrives at the museum, a student registration piece on tablets. There's a bracelet with an RFID tag for each kid. They get a unique identifier through the bracelet. They take their picture all on these Nexus 7 tablets. This is a little picture of what the current hardware setup looks like. Clearly room for improvement, but everything's working right now. And then we start playing the game. The game is something like this. There's a challenge about aliens. By the way, these are middle school physics kids who are learning about conservation of energy. We won't get into the details, but they see these kinds of challenges on the tablet. They have two tools to solve the challenge. They need sizzle and oomph to do those things. They have to pick a map, and what they're going to be doing is going down the slide. And the slide has, a little hard to see here, but there are some pressure sensors. You see the black lines inside the slide. Let's see if I can show you right here. So these are pressure sensitive sensors. The kids are getting their velocity measured at the top and bottom. Their mass is measured during registration. You can see on the outside of the slide, it's just these little boxes glued on there with some Ethernet cable. And then when they get to the bottom of the slide, they get to see how successful they were. So we're trying to support some little mini inquiry cycles by just getting you to want to play the game better and better. And then, as I said, this is where I think things get interesting. We take that data and come back to the classroom where we have an app. This isn't skinned yet with all the assets, but picture the same images with the slide and the aliens. And we now dig back into this data back in the classroom. We can replay the exact runs that you or I did, so we can pull them up by individual name. And then this is still in process, but we then sift and sort that data with the support of our teacher. So this is very much like an inquiry lesson happening back in the classroom, but with data that we collected on our own bodies going down the slide, and I can look at mine or my friends, and it's sort of our whole class corpus of data. And if we do it right, we can see conservation of energy, we can see the ingredients for each of those energy types by looking at that data set. But I think this is an example of sort of I'm trying to pitch it to you guys as a really broad question about, we have these kinds of facilities, you know, these are resources for us, these kinds of museum settings, whether it's a science museum or a natural history museum. You know, what can we do with technology to take an experience that happens that is much, you know, different than the typical field trip where you run in, you run out, where something's captured from that experience and then sort of distributed back to the classroom for further study. So that's the end of it. Any questions?
Again, feel free to ask some questions as I change out.
Is that a permanent setup you have at the slide?
So the slide is, but what I didn't mention is that the idea here is to make the setup into a portable kit of technology, so that it's not restricted only to this setting at the museum, but ultimately is something that teachers can take to any classroom playground, and or you can do it outside of a classroom setting. And we have a relationship with New York City Parks and Rec, where we might be doing this on some just public playgrounds, and then it's not a class obviously, but you would go home with your caretaker and hopefully look up some of that same data on